So, I am back here today to continue cleaning up my RPG simulator. I got some cleanup started last week, and I was just, before getting into it, thinking through uh, the. I've been thinking through the next steps of cleanup, and I think this context header to dos, like searching through these to dos, we got this tile construction issue. We got the probing issue. That's stuff I want to get to. I want to do a naming pass on the proto layer from like the first couple weeks I've been wanting to get back around to cleaning up that part. And now that I've gone and monkeyed around with the tile protos and the protos, this has gotten even more like relevant. That reminds me, there's also this string map problem. I don't know if it's noted right here, but we need to build out a better string map. Um, that's what all of these are. So maybe proto construction and the string map stuff is a good first spot too. That's a minor thing we'll get to eventually, probably. Are we using lists? It looks like the answer is no. We're just defining them. Let's take lists out. Yeah, okay, that's very long road. Not what I need to figure out right now. This is something about the magic ID system I want to think about. There's a couple things there I want to think about. And then here I've got the gathers, the magic gathered arrays intermixed with a little place here and there, which are now redundant. I can actually just make all of these into a unified ID system, and that might go hand in hand with being ready to do the proto cleanup stuff, because these are the routes and the parties and the characters are the protos that I still have that have not been split. These are the things that were proto in addition to the tile proto. The tile proto split out, but these are all still proto. And so I think it might make sense to have these collapse into a single array actually, instead of three separate arrays, and then make that an ID system. And then we'll have routes, parties, characters as sort of protos, which parallel to an entity system. And then we have this coming idea of a tile board that hasn't entirely taken hold yet, but there's this right here, the build this data structure for the cleanup purposes. So right now I'm representing tiles as entities in my entity system, but I've come to the conclusion that that's probably going to have to change, because the tiles need to be able to be accessed and modified like dynamic variables on a scripting language a little bit. It's a dynamic keying to state that I need there, and it's also It's also the case that I want to attach tiles to multiple levels of the hierarchy. Right now, I can only attach tiles to characters because there's an assumption that the entities that live under a party are all characters, and that's a very useful assumption whenever I make it. But sometimes I wish I could say, look at the tiles on the party, and where are they? Well, they can't be entities anymore if they're going to be on the party. But they would, if they were going to be entities, they would need to be children of that party. But the children of the party have to be the character entities, so the tiles can't go on the parties, right? It's just the upshot of it. So the step of first making the tiles not fit in as entities or as protos feels like a step in the right direction, where we'll have a tree of entities to represent various structures of the game state, and every height level in the tree will be able to have an entire tile board. So, where do I want to start? There's also stuff over here in sim.c to look at. Yeah, this says start with the map data structure. I think that's the right starting spot. So let's All right, this structuring doesn't work. Let me think this through. The way this one was able to work was I had an arena for the buckets here. And what I would do is when I needed new buckets, I would make a new arena, allocate the new array of buckets, and I'd transfer all the nodes. So the nodes weren't actually living on the bucket arena. The nodes were living on the main context arena. And there's the secondary arena for swapping the array allocations. I think what might need to happen here is that well, the handle for what the map is, the handle for the map itself needs to survive the growth of the map's bucket array. And the string nodes, the buckets need to survive the growth as well. So they need to live on an outside arena. It almost feels like there wants to be a heap allocator for the array of buckets instead of an arena. And a single shared heap in the context for managing that array so that it could grow could work. The reason I'm using a growing map, which is something I don't usually do, is because I didn't want to have to think about how big this should be, given that I'm going to have new stuff to add to it all the time. But it does grow slowly, in the sense that this isn't meant to handle user input. This is still this is still a programmer-made construct, right? This is a hash map for looking things up by their data string. Okay. I think the trade-off I want to make here is I'm going to give up on being able to grow the maps for now. And the reason for that is I won't actually be putting as much stuff in here as I used to be. A lot of stuff used to have to bind through the string map. And so I needed display names to map to... I still need that for the scripting of characters, right? I still need to be able to turn names into IDs during the proto-construction phase. I'm still going to go with the map that doesn't grow. Maybe I can give it a variable number of buckets, though, so I can specify them from outside initially. Okay. Connor Timmons is asking if this is a generic RPG simulation system or if it's for a specific game that I'm working on. Well, I think I'm not quite sure that there's such a thing as a totally generic RPG simulation system. So there's no way that you could make a program. I doubt you could make a program that could generalize to any existing RPG. You could, though, thinking about like I think it's more along the lines of what I'm developing isn't necessarily intended for a specific game, although I sure would expect that you could make a game out of what I'm doing pretty easily. In the same way that like RPG Maker makes it easy to make a game, but I'm not sure. I'm not committed to making a game out of it. I'm exploring that possibility, but I'm also working on the simulation system just to play around with programming an RPG and see how I like it, see if there are interesting things to learn from it, and I'm using it as a excuse to develop some other side projects that I've got. So, like, to be more specific, the way I'm coding the RPG is a big part of what I'm iterating on. So I'm using the C language, but I'm sort of tweaking it, or I'm using an undefined but generally available extension to C to organize the code into these sort of things. These things I'm calling C scripts that are these little isolated functions that are tied into the system by some extra data and that relate to each other in special ways defined by the core. So, and there's also like these ones that define the flow of the rules when what kinds of moves get to be made and how they resolve are isolated out into handlers like this. And then the combat system is defined into more of these tiles. So, yeah, that's what I'm doing. But there's no game to show yet. But I did last week toy around with setting up a tile set so that I could visualize this better, which makes it one more step closer to like, hey, could just convert into a game project, if it was feeling good like that. But I'm pretty sure there's got to be somewhere where I'm using proto set name on the tile proto. So I want to, I want to stop casting it tile proto. Now, somewhere else I must be casting this to a tile proto, I'm sure. Here. Things are gonna have to change, though. Yeah, so another question. Are you generating a table of the defined states like sleep, wake, etc., with their associated simulation procedures? Yeah, sort of. So I went a little farther than that. So the basic idea of the simulation is that it's sort of a flow chart of states, and in each state there's then some procedure that tells you the rules of like what kinds of moves you've got. So like, do you at the beginning of combat you decide if you're going to try to fight or if you're going to try to run away, and then if you did decide to fight, you can. How is fight flee the first one? Why isn't fight the first one? Did I accidentally delete something? Where's fight? Fight. Oh, here it is. That order is kind of funny. Okay. So then what happens is there's a rule here for what you do if you decide to fight. But I have a little bit of a like game theory perspective intertwined here, which is that there are two parties and each one is making decisions. So I actually give a state to what I'm trying out in this specific system is that each party is in a state, and we dispatch from the set of states of both parties while they're in their encounter. So like this is the beginning of the rules for an encounter, and each party makes this decision. And then if both parties decided to fight, then this resolves what happens. But if, for instance, I decided to fight and the opponents are running away, then I actually convert into a chase, and there's a different mini game that can play out with a slightly different contest and a different set of moves that will be available, or a different subset of your moves at least, right? The context is a little different, so you can't use your usual attacks, but you can try to chase them down. If you succeed at chasing them down, you end up right back at the fight. But another combination that can happen that is simulated by this is that both parties can choose to flee. And the way it works is if you choose to flee, you go first. So in combat, both parties are simultaneously making a fight decision, and then the moves get shuffled together and played out according to the rules of combat. If you run away, you go first. You do everything, and the opponent gets to see what you did and try to catch up. So you have to run away by being uncatchable, basically, right? But if both parties chose to flee, they would both make their move simultaneously again before they find out whether or not the opponent is even trying to chase. Right? You have to kind of, if you're going to run away, you have to go immediately, is the idea. And so you have to commit to expending a resource, or you might blink away and it turn out to be totally unnecessary. And so you want to be smart about if running away from things with resources because you're sure they're going to chase you if you don't use resources, is kind of the idea. And so that is simulated by giving each party a state and then dispatching pairs of states back to these. And then it's symmetric, right? It's a sort of symmetric game theoretic view. So what happens is if the states, if we were to write down a rule for fight versus flee versus chase, for instance, or fight versus flee, then it doesn't matter if the two states come in one order or the swapped order. We map this we just permute what we need to make them match. So if I were to flee and my opponent were to fight, then it would still match this rule, but they would be the ones to get the chase state, and then they would be the ones playing this role while I'm playing this role in the same rule script. So that's how the encounter rules are working. I want to explore if that's generic or if that's only for combat encounters, and if I'm going to need other types of dispatch rules and state flow systems layered together, but that's a little down the line. That's not part of the cleanup tasks that I'm on today. Arena context key hook. There we go. All right, Maria asks, how does the RPG rule script macro register into the table? Okay. We're talking about this one. So there's a couple of layers of tricks going on here to talk through. This is a harder example because of the fact that it's multiple layers. Let me show you let me not get bogged down in minor details. The interesting part here is that I have a couple of ways I can do it, and I'm in transition from kind of relying on one way to thinking it might be better to rely on a different way. So some of them are working a little differently from each other, and I can't remember which is which. But I'm going to go just show you kind of what all of these look like for a minute. Tile scripts. So I think this is... Yeah, so this is using that method. Are any of these using register still? This one is dead. But yeah, this one's using register. So character script, got it. Let's look at this file. Nice. Okay, so there are two different ways I'm doing this. I'm going to show you how I do it for the tile script, and then I'll show you how I do it for the brain scripts, because those are the two that are, or the character scripts. Those are on different systems right now, and one of the things I'd like to do is converge to one of them that I'm finding that I prefer. That's something I'm going to do during cleanup this week, maybe today. But then I'll show you the extra trick that's involved with the rule scripts on top of that layer. So the tile scripts look like this, right? Here's the macro. The macro expands to, first it declares a function. We don't really care for this function to be one that we can name directly, so I use double underscores because I want to make it non-colliding with other things. But I also want to make it unique, so I still pass in a symbol name that I can use to link to it here, right? So I declare a function with that special name. Then there's this piece. Now what is this? RPG tile decal. Well, if you look at what this actually expands into, it's a global variable. It's an RPG tile proto, so a global variable, with the name ID RPG tile enum underscore underscore, and then whatever the symbol is, right? So that goes there together with this thing. This tells it what section to put the data in, so I'll put that there. You can imagine this being like protected, for instance. So the protected ends up right there. And then we get some braces that get filled in. So we get, this is essentially saying, you can imagine it's like, this is my way of treating a C string with a length in a static initializer. So this can say protected in this case, so it's going to take that. You can imagine it's plopping it down there, but it's some kind of version of a C string that comes with a length. Or so not a C string, you know, it's a length-based string somehow. And then that function name that we declared gets linked in right here. So here we've got our hook, right? And then up here we have function void hook RPG context, something like this, right? So here's what my hook signature looks like. I pre-declare it, I put it here, and then I go, and we can call this, like maybe this would be called hook protected. That's not the real name, and you can obviously see, but I'm making it a little more manageable here. So then finally, it uses the same thing it did in the first line. Why is it doing that? Well, because it's this. You'll notice the only difference is there's no semicolon. That's why I can then put a brace there, and that's what all of this becomes, right? This is just that. That brace there completes the function. So the first one declares it so that I can stick it into a data structure, into a struct, a global variable, statically. And then the second one exists so that I can define the function on the same line, right? Or within the same code. Now, the reason for, I'm going to take this part out. The reason for all this is what we're doing is this here isn't a struct. This is a special section name that has been set aside for this particular array, right? The tiles, each tile is unique because it gets a specific tile proto somewhere in the RPG TL section, right? And nothing else is touching that section. So the only thing that's going to be in that section is a series of structs spread out as if they formed an array of that struct in memory. And that's going to be initialized statically at the beginning of the program. Then all I have to do to use this, that's how it gets registered into the table, is it's just a global variable that happens to be next to all the other global variables of the same type in order to form the table. So the table is literally just declared. That's why I call it C scripting, is it's just declaratively putting together a soup of stuff into one big array, a big data table. Then the only trick that's left is at the beginning of the program, I have to take that array and find it somehow and then process it. And so the way I can find it right now is, say, for instance, here we're registering. So these went into RBGTL, right? Well, what happens is everything in that section gets processed ahead of time. And I'll show you how that happens into this RPG tile enum, right? This RPG tile enum is the name of the enum. So I'm still trying to converge on a naming scheme here. I'm calling it an array. I'm also calling it an enum. The reason it's an enum is that it's a system of identifiers. Each tile, like the protected tile here, gets a unique ID, and the IDs are small and consecutive. So there's somebody uses 1, somebody uses 2, somebody uses 3, somebody uses 4. We don't skip out to a million and leave a bunch of blanks. They're small and consecutive IDs. So enum in that sense, giving each of these identifiers a statically, well, not statically, but before link time, by the end of constructing this program, it's not known by the compiler exactly what the value of each enum will be. So we're not counting on it for that purpose, but we are counting on it for the purpose of assigning these IDs by the time the program runs. And then those IDs index into that array. So I have these IDs, and if you've ever used C enums, one of the things that sucks is you write down all this useful set of codes. You are assigning a symbolic name to each number, making a coding of some concept, and then you want to put some of that coding into some data, let it do some computational work, and then see your codes, but they come out as numbers instead of as names, right? Because they are just integers under the hood, and C doesn't preserve your enum names in any way. And so you end up wanting to do things like having associated string tables or a meta program that generates all of this or whatever. What's happening in this version is that metadata is why we have an array that goes with the ID. So each of your names, like this protected thing, gets some unique ID, a small consecutive ID in a small consecutive ID system, right? And then that ID is an index into an array of metadata with things like display names, and if you want, you can tie in a hook or some. Another case is down here. I create these things called character literals that are just these little strings that I want to parse. And the reason I'm doing this is because I'm trying to define a way to very quickly describe a character. And I might not need this forever, but this was how I got things up and running and got to play with lots of different character designs quickly in the first 6 weeks of prototyping with this idea. And so the notation I came up with was this, and I wrote a tiny little parser that turns one of these into the data structure for generating characters into the simulation, right? So I can generate farmer characters, and this is the formula for a farmer, or wizard characters, and this is the formula for a wizard, and so on and so on. Now, is that little C string scripting system helping me? I don't know. I actually need to still do some experimentation on other styles of trying to specify these and see if it feels better. But it is probably the best way I could find to make a very dense, terse description of these. And you could imagine that these might not always be good enough. I might need to expand them. But another thing that happens here is now I'm tying in not a hook, but just an identifier name so that I can reference it statically with a small consecutive ID, a display name so that I have something to print and also something to reference inside of some of these little C string scripts, and then a C string key value that gets parsed at init time, right? So this gets stuck into the table too. So the point is I can now make these enums, which are open enums. They are the values get defined not in a single sequence of code, but throughout the program. You can register new IDs by just declaring a variable of the correct type and putting it into the correct section. And what that does is it doesn't set the ID for that thing, but it guarantees it will get one and gives it a spot for storing all that metadata. Does that make sense? That's the first half of how it works. It registers it into a table with all of the metadata that you can pack into it just by just making a global variable and putting all of the global variables of the same type into an array. And then at init time, we find that array. I skipped this part before, so I'll show you now. At init time, I have a function that runs before main to do a little setup. It reads out that section name. So you can imagine this is saying find find the section .rpgtl. It finds that section, and that section is just a block of memory, and it figures out how many elements there are in that section and where the base of that section is. This is a part of what it needs to do in order to convert between the small consecutive IDs and the and indexing into that base of that array to access the metadata. So that's the data section hacking version of how I'm registering stuff. There's another way that I was doing it, which is by leaning more heavily on this before main system. So the way before main functions work is they're just functions that you write, and then you set them up as something that runs before you go to the entry point, and you count on the C runtime to have an implementation of this, because the C runtime itself wants to be able to initialize itself, and also for C++ compatibility, the way you implement constructors that run in global space before the main function runs is through the exact same mechanism. You have a special data section with an array of function pointers, and you are just going to, and the C runtime grabs that data section, same way I'm doing here, essentially, and iterates the function pointers in that array and calls them all. So that already exists, and this is just hooking into that. The other way I was doing it was saying, instead of having a global array in a data section, what I can do is for each thing that I want to register, I think of it as not a matter of putting the right data in the right place, but as computational work to do before main, right? And so then I can write a register macro. The register macro is basically another version of Mr. Forth before main, except you don't have to give it a name. It generates a name for itself. It generates unique names for the registration functions. And then what happens here is we can call this register function. All register is doing is creating one of these data nodes in a globally set up linked list. Now the before mains, there's no defined order about when they will run, but they are not going to run on separate threads. They run serially. So all you have to do is make sure that you're not assuming anything about the order in which they run, and you can access a global variable, right? Like a global data structure. And that global data structure can then be a chain of the things you wanted to register. And the upside to doing things this way is that this can now be a little more arbitrarily complicated. But realistically, it turns out I still kind of just want whatever I can fit into a macro, which is why I'm thinking I can go to the global variable data section version. It turns out I still end up wanting these global sections, these data sections anyways, because even with the registration system, I still don't have a solution for small consecutive IDs. And this new magic ID system turns out to be good enough to handle small consecutive IDs and binding static metadata to functions and other data literals all in one go. And so I'm going to lean all the way into this over time, I think. Paging Turner asked, do the before mains get run in the order in which they are defined? That's been my finding on compilers. But since this is undefined compiler extension stuff, it's not something I want to count on. And that stops meaning something when you start having linkers get involved, right? If I have three object files all defined some before main functions, then now it's not just about the order of declarations or definitions in the C file, it's also about the order of the linking. And again, you can say, well, aren't they going to run in the order that you put them in the linker? And it's like, yeah, as long as the linker is working that way. But again, you have to go and check what each one of them is doing. And well, what they're guaranteed that they have to do logically is they have to run each function. They are not guaranteed logically to do anything in particular about the order. So I'm just trying not to rely on that. But it's true, they tend to just come out in the order they were defined in. Kind of like they would if you were writing like a Lua script, then you can imagine you can have a main function, but that's not your entry point. When you run a Lua script, what's happening at global scope is what happens when you ingest the script and run it for the first time. Like when you set the script up and do it, the global scope defines what happens to start the program, right? And there the order is defined because that's the point. This is almost that, except C wasn't defined with this idea. So you got to be a little careful about what you think the order of things is. Mm-hmm. I think I think it's a little bit of an arbitrary line, right? Whether or not you want to assume they run in order. We're already stepping into we're already stepping into the cursed black magic section of programming. Like, we're doing forbidden things here. So having some kind of guardrail against insanity still feels reasonable to me, even in that space. And especially because I want to be able to pitch to people who are going to be real turned off by the idea of stepping out into the black and having some limitation that I'm not trying to violate, that I'm not trying to push past, gives me gives me a way to say, like, hey, look, we're not this isn't Wild West here. We're still thinking through what we can and can't rely on and how we can and can't use these. And yeah, the C language wasn't built for this, so we're going to have to be a little smart about what limitations it doesn't express to us properly. But we can handle that. Okay. So hopefully I've answered the questions and it's looking good. I do want to show you the second piece of the complexity here. So the rule script has this thing that's a little nasty. That's that I have a variable number of things that I want to tie to it. And I don't know the best way to deal with that yet, because for that to work, I'm doing another piece of arcanum, which is I'm using variadic macros. All right, so the first parameter here is saying how many parameters there are, because variadic macros don't have a way to do that across compilers that I know of. And then with that, I can create an array. Now this code comes out as a statically sized array with these as the values. What I would love to be able to do is something more like this, to say we're making a rule for the fight, flee states. But there are two problems. One, I don't know how to deal with the fact that the number of parameters isn't known unless I put it in there. And two, I can't, with a macro, find any way to apply something to each parameter but keep it as a list, right? Basically, I have to use the whole list as a single blob, right? And so the blob has to include the wrapper of getting this. And then the third sticking point here that sucks is normally I would just call this state, but this is currently a before main, right? And if I switch it to being a statically initialized like data table thing, it would still be before I'm guaranteed that the enum has resolved, right? So the fight and flee states are in one of these enums. Where is this? Fight. I think it must be here in combat. The fight and flee states. Where are they? They've got to be around. Maybe it is here. Fight. Yeah, here we go. So we have a state definition for these 4 states. The fight state. The fight state has the property that. Wait, what am I trying to say? The fight state. It's one of these enums. Right, so what I was trying to say is it's one of these enums. I would usually want to refer to it by just saying RPG state fight and RPG state flee, but these don't get resolved until one of these before mains goes off. And so that means this can happen too late, and so the count and bias aren't known. And when the bias isn't known, this way of getting IDs stops working. Now, there's a way I can fix that that will require us to go beyond the C language. We'll have to start modifying our object files directly. And I'm going to go there. I just haven't gotten there yet. It's a good question. Let's take a look. So Maria's idea here is to say leave out the num, just use the VA args here, and then if this was like this, and if there were 2 elements here, then this would automatically fill in a 2. Size of args is already how we do it. And then this would be an array count on args. That might work. Then I could drop the num. That's the idea. That seems kind of cool. Okay. Okay, nice catch. There's one problem solved. Well, that's fake. Where am I still referencing num? Show me. Right, okay. Don't pass the num around anymore. I think that might have worked. I've broken a bunch of stuff, so I won't expect that to be a fair representation of if the idea worked. There's still a problem here, though, that the way this has to work right now because of the variadic arguments is that I need to make a copy of it at runtime first, and therefore there's a bit of a problem with registering these variadic arrays of things. I got to come back to that. That's a part of the cleanup. We'll get to it. But yeah, that's how it all works. Paging Turner, right? That's exactly what I'm saying. Like, there should be a way to create a resolved set of IDs. Small consecutive IDs have a bunch of advantages over keys like strings and even pointers that are scattered around in the 64-bit address space. Small consecutive IDs push what you can do a little farther, because with that you can start thinking of indexing into arrays of things. You can start thinking of having a single index into like a secondary metadata that dispatches to an optimized data structure that packs things in tightly, or whatever you need, right? And so I don't think that a lot of that stuff about like dynamic programming, not as in dynamic programming, isn't that the name people use for algorithms that have that cache the results in a data table. Um, Not that. Whatever. That's a terrible name. Whatever. Forget that association. If that is the right word. But the dynamic composition of pieces into systems could be done without sucking, I think. So JD asks, could you explain the keyword static in a simple way? Yeah, so I could. I think the best way to understand it is with a picture. So do I want to switch to drawing this out for you right now? I'm going to explain it without drawing a picture, and if it's not getting through, then maybe I will take a break to actually show you the full picture version of my explanation. But the static keyword in C, first of all, it means different things as applied to different pieces, but the and in different contexts. So what it means does depend on context, but the key idea, as it applies to global variables and to functions, is whether or not this is a variable which will be visible to the linker or which will get entirely resolved in the compilation unit. So with C and with old school programming languages, there's a two-step process. First, you turn the code into an object, and then you take one or more objects to a linker to convert that into the program, right? So when you have source code and you're converting it into an object, some amount of linking happens there. Let's not use the word linking because it's overloaded. Let's use the word binding. So we have some code that defines what X is, and we have some code that defines what to do with X, right? And those bind to each other through the name X. If that binding can be completed, if all of the definition sites and all of the usage sites can be contained inside of a single compilation unit, then we can make them all static and let the compiler hide the fact that this thing even exists from the linker. There doesn't need to be a symbol left behind in the object file. The object file is like converted what used to be this named X thing into just a web of references and uses and definitions, right? But the web doesn't contain the name X anymore. The binding through that name X is complete, and the name X can be dropped. If you don't mark something as static, and it's a function or a global variable, then the alternative is extern. And now I think that variables are static if you don't mark them as static, but functions are extern if you don't mark them as static. Like, there's a different default for them, and other annoying stuff happens. Static means something slightly different if you're inside of a function scope now, because a static variable inside of a function scope has the same property as a static variable outside the function scope. But the other implication is that it's not a local variable to the function, right? Which is a little weird. But the whole point of it being static is that the binding gets resolved by the compiler, and the object file has no symbol inside of it for that name. And if something is extern, which is the opposite to static, to the alternative, then there is a symbol in the object file, and other object files can reference or define symbols for each other, so the linker will finish the binding instead of the compiler. Hopefully that helps. Hopefully that makes sense. Okay. I think the thing I'm most concerned about right now is there's something crashing, and it's probably to do with the fact that this might still be getting used for brains, even though it no longer contains the brains. How is that compiling? Oh, this is old RPG, I see. Okay, yeah, so none of these are relevant. How is that compiling? Who knows? Somewhere around here, something isn't right. Might just need to use the compiler. I might have lost the thread of what I was thinking about. Or the debugger. Did I forget to initialize the brain map? Is that the issue? Yeah. There we go. So there's the simulator running a fight through to the end. Let's see what's happening. Looks like they're fleeing every time. Let's go see about that. Combat. Yeah. Set the default brain back to fight every time. And there we go. Now they can fight it out. And we're seeing the player party can sometimes lose a couple members, but it can sometimes make it to the end with all of its members. So there's a lot of variability on how dangerous this particular encounter is for them. All right, I'm at an hour and 25 minutes. Now's a great time for a 5-minute break. I'm going to set up the sign real quick. All right, 5-minute break. Here we are. Ugh. Apologies, I thought I hit the OBS unmute button. Maybe I missed it earlier. So I've mostly just been saying, nice, looks like the maps are up and running, but the brain map is still a little off, and I am... Where was it? Yeah, I am replacing the old, like, printf keying, which was being done because I only had one string map, and I was already sticking arrays of integers into the string map for the rules. So when I also was beginning to stick brains in there, I was like, oh, I need to somehow distinguish them. How about I use strings with numbers written on them, and we'll fix this soon. So now I have a separate array, map for brains from the rules map, and so I can just stick in these buffers of integers like this, and we're good to go. Except that my base layer doesn't actually have an idea like this yet, where it takes in an array buffer. So with the struct version, it's going to say that S is a pointer to a struct and use the size of and dereference that. If it's an array, then it'll let that array decay into a pointer and cast it to a U8 star so that it'll fit the function here, and then use the size of the whole array without decaying it, because, you know, C's got that really weird relationship with arrays and pointers and the array types and so on. And the pointer decay thing. Yep. Okay, so that's working. Okay. The next to do here says upgrade the magic IDs. I guess that's... might as well do that. I was saying that seems like it might still be on the docket here. So why don't we get that done? Okay, so you're using the ID system, you're using the ID system, you're using the ID system, ID system. Here's a magically gathered array. We're going to switch everything over to IDs. So let's see, what are we looking at? Characters. Excellent. So what we're going to do is the RPG entity protos. And we're going to give it something like this. This is going to be the proto enum RPG proto ID, and let's see. So its type here is a little unfortunate. So the proto has a kind, brain elements. I think all it needs here is a script. And this is going to be an RPG proto. Reference define. And now, what we do is we don't define them this way. We go decal equals, and we put down the global variable right here. And this needs to be a protokind character, which replaces the need for labeling it like this. It's going to have a display name set like this. And it's going to have a script set like this. And the rest will be left blank to be filled in later. I don't actually think any of them use a brain yet. I think tile brains are the only ones I have. Now, if that's working, then I should be able to take out all of this, and I just have to replace the other two. So these are pretty much the same. I'm just renaming them, essentially. But I'm re-implementing them at the same time. So those evoke these now, rather than invoke it. And these just set up these protos. Then, at init time, instead of this, I can do, let's see. Okay, there we go. They're collapsed down to one single array of protos now. And then we visit each one. And we call proto init. Now we used to do proto init from reg data, but that's just actually going to go away because we've gotten rid of the registry on this level. So this is just proto init, and it just initializes itself from the data that it's declared with to a set of data that, let's see, we've actually eliminated protokind init as well. And this is init from reg data, but there's not going to be a reg data here anymore. What's going to happen instead is the kind will already be encoded in the proto that we get. So this is just going to be like what used to be something we were deriving is now something we know, and it becomes the subject of the switch. And so all that's left to figure out is how to parse the script, which is what that part does. And then we do, what is this? This is basically if parse literal func does not equal 0. Now there's no reg data putter 1. But we can check out in the old version what reg data putter 1 would have meant. That's the script. Right, so this is where we want the script. It says right there in the variable name. I could have just read it. So really, we don't need this. We just stick that there, parse this out. Init from literal. And then proto set name comes from the proto name. Now, what is init from literal? That's pretty interesting. That's coming in from the world of how the little script parsing works. Once it's created one of these literal structs, it's like a tree of these things called literals, which are the direct output of the parser. And it does a conversion from the thing the parser doesn't do is it doesn't reach into things like the tiles, IDs, and stuff. The parser is just a string conversion layer. And so the literal is the data structure that represents the parsed result, but that doesn't know anything about the tile engine and the RPG engine. The proto is the thing we're trying to build. Yeah, and that's this piece here where we have... Okay, so we do want to touch the protos again to deal with the tile board change is what's going to change this up next. So I think that should be fine to stay as it is. The subliterals get constructed from new protos on the fly that don't come from the array of proto IDs, which is okay. That doesn't cause any major problem. It just means they don't come with a script or a display name. Mm. Okay, so now I'm at the point where I can start using IDs for all these things. And I think I want to push in that direction. Because now what we're looking at is like proto equals RPG, proto from ID. And yeah, these connect straight to protos through pointers and not through IDs right now for a very good reason, which is that some of the protos are generated on the fly that are not actually in the original statically declared array. Looks good to me. Cool, 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 cool. Let's see. Where to next? Everything appears up and running correctly. The sim thing here says, well, I was transitioning to getting rid of the gather array stuff. Maybe I can check if I have anything left to do on that front. These are all done. Were there any other gathered arrays here? Now the brains here are an enum. Okay, I think that's all the uses of the gather system. So I'm gonna go just delete those real quick. Because, like I said, they're kind of redundant now. I've collapsed it down to just the ID system. Alright, where are we at in terms of the registry? Because I feel like I'm getting closer to being able to eliminate that. I don't use this anymore, right? This is the old system. Okay. I'm looking at the registry for the current system. RPG, reg data, kind, tile. Does it get used anywhere in the new code? Just right there. Tile brain is getting used there, there, and there. Character in the new system, it's getting used there, and that's all gone. So that's probably all of you, huh? So you do process the reg data from the rules. Okay, so that one's not ready to go yet. Okay. So I think we try to track down if we can eliminate these. These are the old ones, but this one here, what does it need to do? It just needs to modify one tile proto. Well, why don't we just... Okay, so this is where things start to get interesting. Why don't we just do... Maria, that's awesome. Super cool. All right, let's try to replace this with something that doesn't use the registry. I actually think it's good to go. I'm going to rename it, though, Brain... Brain script tile. So we want to write down the name of the brain, the name of the tile, and that's it. And what I actually want to do is use a magic ID system again. These will be the tile brains. And they're going to use a struct that I set up right here. And then what I want here is to not need a new symbol name. I actually just want this for the array. And I still need the whole enum system because even though I'm not binding the IDs, I still need small consecutive. I still need to know everything else. I need to know the count. I need to know the base of the array. So this is still correct. It's just I want to do ID decal raw. So I want to do ID decal, but I want a version that's like so it's always already going to get this. This is just going to be if that works, I can just go ID decal nameless RPG brain tile enum equals, and then I should be able to plop out these two. This is brain raw, brain, RPG tile raw, tile. All right. Right. Okay, I did miss one important thing. Brain script tile. Question in the chat: how do you handle errors in C? I'm not going to answer that right now because it is super off topic, and I've made a whole video on the subject. So, go over to mrforth.com. This is my website where you can follow all sorts of stuff about my projects. If you go to videos and check out, no, it's not this one. Go to the, go to this one here. But you don't necessarily want to watch this. But here on my channel, if we have a look, switching to C, better errors. So go check out this video, switching to C, better errors and development tools. I talk a bit about how my error system works in this video. And I think that might have been the last time I talked about it. There was an earlier iteration of errors in some of the other spots too, and then that's where I like totally cleaned it up. So Let's see. No error system there. No error system there. Thread context. Yeah, you might want to check out this video. Upgrades 2022 is also going to have a little bit of stuff about errors in it with the relative to the thread context part. And I will explain the basic gist of it though, is that handling errors isn't a thing. Like, it's not real. That's just programming. And so you just write the code to do the right things. Like, the idea of errors is very made up. Like, it doesn't correlate one to one with a specific pattern. It's a different problem in every domain. So compiler errors are different from missing files that need to, when a file that you're looking for is missing, that's a different kind of thing. The feedback, the user is a different kind of person. You provide different kinds of information. So there's no generic such thing as handling errors. Really, the question of how do you handle errors is a way of shunting off the part of programming people don't want to do and pretending like there's a quote-unquote error system that auto-handles it. But there's no such thing as a system that lets you shunt off the dirty work, because it's not the same everywhere. Different errors are different things. Okay, what I forgot to do was to set up the hook. Oh, trust me, I didn't answer the question. There's a whole bunch of stuff about thread contexts and string errors and stuff. There are like tools that I use. Then I'm not going into that. I went into the meta of handling errors, not the tools that I use. But point taken, I answered the question to a certain extent. Whatever. Okay. Okay. So now what I'm changing to is there's no need for brain scripts to link so I used to have these things called tile brains. It's a brain script. A brain script describes not the rules of the game, but the default behavior of like a bot kind of player. And what I used to do is just say that each tile would come with a brain script, and in order to link them together, I was actually relying on them using the same display names so that I could link them together through the name tables. But my systems have got good enough now with these IDs and stuff that I can actually link them together through these statically known IDs. So now the binding of this brain script to this tile is done without the need for the display name. What I'm adding is that there are multiple layers of the brain. I have a default brain that does the default stuff, but then there are going to be specific bots that want to be programmed to behave differently, and what I want to do is take them and define the part of them that is special, and then place that inside of a default brain so that if somehow the player manages to get one of these bots out of its usual expected set of states, it still has a default set of behaviors that make some kind of predictable sense and it doesn't crash and all that, right? And so whenever I create a brain, whether it's a brain for handling a specific state of the flow of the rules or a brain for strategizing about whether or not to use a specific tile, I want to categorize that brain as being a member, that brain script as being a member of one of these brains. And right now I have a default brain. And later I might have like, oh, why don't we have a different brain for wake up that's for the I don't know. the default brain says if you have uh, an ally who's asleep, if you have the ability to use a wake up tile, then just go ahead and do it. But why would you leave somebody in your party asleep? The first thing that comes to mind is you might be. I'm trying to think of. It's a weird example, but like you could imagine you have a boss and he doesn't like spending time to wake up his minions, so he just does nothing. He doesn't bother waking up his minions if they go to sleep, something like that. Um, so it might not be that it's actually strategically better. It's just that the rule is going to be bosses don't wake up their minions. You know, they don't give a shit about them or something. Or another alternative is maybe this specific um, the specific dream boss gets some kind of advantage from being able to have allies who are asleep, so it's against his purpose to wake them up, right? Whatever. Another example I have of this up here is the idea of the thief brain, which is going to want to run away after it has stolen enough stuff from the player to its satisfaction, right? So a thief brain plays out the fight flee choice differently, in theory, right? That's the idea. So now when I make a brain script, I have to, instead of linking a string name in, I have to specify what brain and what tile I'm talking about. Brain script state, brain script tile, please. These are all just aspects of the default brain. Tile script, brain script tile, default brain. Uh-oh, something bad is happening. Why don't you and you link up as a scope? That's why. Okay. Default run. Tile script. Brain script tile. Default protect. Default sleep spores. I think that's all of these. Right? Okay. Do we build now? Okay. What did I get wrong? something you still don't like about this. I'm not sure what yet. I'm going to expand this in place here in order to get better line info. So you looked like that before. You're going to look like this now. Brain script, default wake up. Default wake up. Default wake up. Default wake up. What's the matter? Oh, let's just get that out of the way. Yeah, you don't like that name for some reason. But why? What's the matter? Brain tile enum sec name. This works everywhere else. RPG brain tile. There's not another tile script or brain script before this one, is there? No, this is the first one. This is the first brain script, I think. Yeah, you don't like that, but why? Mr. Fourth sec name macro works for you most of the time. The type is brain tile. I mean, that's got to be a real thing. RPG, RPG, RPG. It's right there. RPG brain tile. This isn't like you've zeroed out or anything, right? Why? What am I missing? Identifier foo. Did I get something wrong about the setting up the hook? No, you do function, hook, signature, and then symbol name, semicolon. This just looks like a regular old-fashioned global variable now. What's the problem? How is that? And if this was this, what would happen? Right. And if it was this, I assume you'd be fine. Yes. Okay. So my best guess is the RPG brain tile somehow isn't making it in. But like, why would that be? Brain tile. Brain tile. That's it. think this might be it. There we go. What do you mean it differs in levels of indirection from tile proto? Tile raw. Oh, this is skipping the ID system. That's funky. What? Okay, so now everything is fine, except references to RPG brain tile. But foobar is the same thing. Wait a second. Okay. If hook is here, how are you linking successfully to this? Why isn't the syntax error all the way up there? Good. So hook just must be getting identified sooner. Like proto must already have made the hook. Yeah. So you're actually too late. That's why. Okay. But then why does foobar succeed where brain tile fails? Isn't that bizarre? Brain tile and foobar are basically identical at this point. But if I use the brain tile type, I get gobbledygook. If I use the foobar type, it works. How can that be? How can that be? How can that be, huh? Okay, so foobar works, brain tile doesn't. Look for something about brain tile that is still different. I mean, this is what's different. So that doesn't work. But does this work? RPG brain tile? Then boom, fail. How? How can that be happening? Oh, look at this. I dropped the type def somehow. Oh. That should work now? But this doesn't link by string anymore, so they have to actually be in order and come live over here in the combat script. Decompose. Tile script, brain script. That isn't a brain script, so it doesn't do the default speed thing. It still needs a display name. And we're stuck. The reason we're stuck is because I've only half linked up the new brain data. Okay. And what we want to do here is just with each brain tile, we have a specific brain and we have a specific tile. We already have a concept of brains set hook. What is it? Brain state set hook. So I think we just want the same thing, but instead of states, we want tiles. Context, brain ID, tile ID, hook. We're going to get the hook from the brain tile directly, but the other two, the brain ID and the tile ID, have to go through ID raw from or ID from raw, where we go RPG brain tile enum, brain tile brain raw. Okay. And all of this is necessary because I haven't finished the object editing tech for the Magic ID system yet. That wasn't everything, apparently. Wait, you know why that's not everything? It's because this isn't the way I want to do it. I'm thinking unclearly now. Well, maybe I'm not. This is kind of a good moment for cleanup. So what's been happening all this time is I've been saying that a tile gets a brain, but now that I think about it, if a tile proto gets a brain, then that's the default brain for that tile. But where are the brain overrides going to come from, right? So I don't think that the proto for the tile should know about the brain pointer. I think what should happen is that we set it into a data structure like this, at least for now. Later on, the brains might be optimized differently. I'm kind of just sticking them in as keys into a hash map here, but there's probably better structure that I could go for. You know, I could have an RPG underscore brain struct, and it can have a parent that it inherits from, and it can have a dispatch on like looking up these hooks faster and tighter than what you can do when you have to hash an array first, right? These are small consecutive IDs. If each brain was a data structure for indexing hooks off of these, I could probably condense the things and have them flow together as an inheritance system or a mix-in system of some kind much more freely. So we're moving the brain from the tile proto. That's going to break stuff, and then we're going to replace what it breaks with the new tile system, the new brain system. So we come in here. We've got a tile proto. What are we doing with the tile proto? Well, we're checking if it has a brain, and then we're calling it. Well, so we're not going to need the tile proto anymore. What we're going to want is to get the brain off of the RPG brain get brain tile get hook context. For now, we're just talking about the default brain everywhere, and character move tile ID. So that should get us our brain. If that does not equal 0, then we do everything else the same in terms of calling it. And boom. Is that it? No, somehow we're still missing something. Okay. The reason brain failures lead to infinite loops, by the way, is that when the players stop making moves, they never deal damage and never resolve the combat. So monkeying with brains has always been the #1 cause of infinite loops in this project. I could have just set a limit on the number of rounds in order to deal with that. Oh, what happened here? Why didn't I see the message? There it is. So now I won't get infinite loops. I will just get a message letting me know what happened, that we are effectively not making progress on combat for some reason. Okay. Now why? Why? The question I guess that I have first is, do we register context. Yeah, sim.cnew. Do we actually register the brain info that we need to register? Brain tile set hook. Is this getting called with the right info? Oh, these are just wrong. This should be the brain enum and the tile enum. There we go. They duped it out. Player party's getting shredded up. Okay, that's a little better. Looks like they're tending to end with 4 health after that combat. Okay, I'm going to take my lunch break now. We've been at it for almost 3 hours here. I'm going to take my lunch break now. Let's think about what I'm going to do next when I get back. So we've got... the registry no longer contains tile brains, so we're getting closer and closer to eliminating the registry. This was achieved by using a new twist on the idea of the ID system, which is that here I don't want the data or the IDs. I just want to create a binding between some already existing data. Like I want to bind a brain and a tile together with a new hook function, right? And for that reason, I'm sticking them all into an ID system just so that I can get the metadata as an array on startup in order to process it. Just letting some new ideas play out for a sec. I think there's another direction of fun to explore someday, but I'm gonna leave it off. I'm gonna leave it off the table for now because it's a whole nother ground up reimagining. I guess what I'm thinking is I wonder about placing executable code like these hooks in a section other than the default.txt section. And I wonder if there's any reason why I can't do that, and if there's not, I think there might be a really good way to use that to make this a little more generic, to at least make some helpers to go with the system, and I don't know, there's some possibilities. So besides this, what else do I want to get done when I come back? Could work on display names. That seems good. Might not go to object file editing today. Tile proto upgrade. Switch to separate hooks for each clause. Yeah, so we could start working on the tile scripting. I could also go through my to-dos over here. I have some renaming to do, so I want to keep that in mind. All right, I'm going to sign off and get some lunch, and I will be back in an hour or two to pick this up again. All right?